I built what might be the most vulnerable .NET application in history, and I didn't do anything crazy, just used normal framework features. That alone is enough to fully compromise it. Privilege escalation, data exfiltration, remote code execution. More than 50 real-world vulnerabilities, the kind that exist in production apps right now. You can be a great developer and still produce code that leads to security incidents with your name in the commit history. Statistically, you probably already did. Web or desktop doesn't matter, because security bugs don't look like bugs, they look like normal code. Desktop developers often think security is someone else's problem. Web apps get hacked, servers get breached, APIs get exploited, but desktop, it's internal, it's safe. Well, not really. There are still millions of enterprise applications running on the latest, officially supported .NET framework, banking systems, heavy corporate tools, legal software, and many of them can be compromised because of built-in framework functionality you cannot easily disable. Let me show you. Here is a simple WPF application. A data is bound to a database, users can edit, copy and paste rows. Nothing unusual. Now watch this. One user inserts a specially crafted object into the data grid, another user selects the row, presses Ctrl+C, Ctrl+V, and at that moment arbitrary code is executed on their machine, not because of your business logic and not because of unsafe reflection, because Clipboard in .NET Framework internally relies on BinaryFormatter, and when that paste happens, BinaryFormatter deserializes the row from the clipboard and triggers malicious logic embedded inside it. Here the payload only opens a calculator, but in reality it could easily download a malware, pivot inside your corporate network, and here's the uncomfortable part. BinaryFormatter doesn't need custom classes to be dangerous. Attackers can build payloads using system types that already exist in every .NET Framework application. There's even a public tool that generates these payloads automatically, and you don't need to reverse engineer anything. Everybody can generate a payload in seconds, and your WPF data grid becomes a remote code execution tool. Alright, let's leave desktop. Many developers are in web now, and this is where things get really dangerous. Because in web your mistake isn't local, it's exposed to everyone. You think file uploading is straightforward. Validate extension, limit size, store the file, feature complete. Until someone uploaded an archive that could escape its folder. 2 dots, 1 slash, that's all it takes. Your server extracts the file and it doesn't stay in uploads. It walks into bin, into configuration, into executables, and now your backend isn't yours anymore. We've spent years letting frameworks think for us. Module binding, automatic encoding, file helpers, convenience. But convenience hides mechanics. You think Blazor protects us from cross-site scripting, and it does, until someone uses MarkupString or unsafe JavaScript interop, and suddenly your safe application executes attacker-controlled scripts. You think your update endpoint is secure because it requires authorization. But instead of binding a data transfer object, you bound the entire model, and now attackers don't update just what you exposed, they update what you forgot. Roles, flags, internal state, and all in a perfectly valid request. And then there is XML, innocent code just parsing a document, but document type definition can reference local files. So when your parser resolves entities, it might read application JSON, your private keys, or make requests to your internal services, all because XML resolver was left enabled. Sometimes we're so focused on building features that we're accidentally building backdoors. There are dozens of non-obvious security pitfalls in modern .NET, and not knowing them doesn't make you a bad developer, it makes you a normal one. And most of the time nothing breaks, until one day something does. The scariest part, almost none of the vulnerabilities you've seen today look suspicious. That's why they pass code reviews, that's why they survive refactoring, and that's why they reach production. Somewhere in your codebase, one of these patterns may already exist. Not because you're careless, but because modern development hides risk behind convenience. If this video made you slightly uncomfortable, that's good. This discomfort means you're paying attention, because security isn't about paranoia, it's about awareness. And awareness might be the difference between a successful launch and a career-changing disaster. So check your last commit.